Share, already shared. Record, okay. Okay, so let's take a look back. The definition of alpha. So remember the definition of alpha. Sorry. So where the alpha is defined as what? Firstly, the alpha is the angle within a sector. Okay. Sorry, angle within alpha. Sorry, is angle within a sector. So mean for any sector, the value of alpha must be in range between 0 alpha to 60 degrees, or pi divided by 3. So means, so let's say here is angle is 0. So we set the angle reference where D is 0 degrees. So then for V2 angle is in radian, which is pi per 3, right? This one to pi per 3. Here will be positive pi or minus pi, right? So then here minus 2 pi per 3. Here will be minus pi per 3 in radian. So we can define the alpha as the different angle kan. Vector and VA. So you need to identify VA, the first adjacent vector to be selected within a switching period for any angle. So for example, if for sector number 2, let's say we set at sector 2 here. So your reference will be here. So this case, before you define or determine the angle, so you need to identify what the vector of VA. And so this case, sector number 2, VA will be which one? V3 or V2? So mean the first adjacent vector to be selected in sampling method means in interval number 2. So for interval number 1, for any sector, the first vector to be selected is V0. Where the state are 0, 0, 0. Then the first adjacent vector, interval number 2. So this case is V3, right? V3 or VA. So mean this case, your V3 is VA. Okay, so mean the alpha will be here, right? So this is your alpha. So where your alpha, if you look at the coding here for sector 2, this is sector 2, right? So where to calculate the alpha, which is the difference between 2 pi per 3, mean 2 pi per 3 and the angle of the space vector. So let's say this is the theta. Okay, clear? So where for sector 2, your alpha will be the difference between 2 pi per 3 and theta. So it will be here, this line. Okay? Okay, let's go for another example. So let's say now your reference, I think which one? Here. You go for sector number 3. So this is your reference. So first you need to identify the adjacent vector. So VA, V3, right? V3. So mean the alpha will be here. So this is your alpha, the angle within sector when the vector lies in sector 3. So where the alpha can be calculated as, so this is for sector 3. Here will be sector 2. Sorry, sector 2. So where the alpha is the difference between this angle, right? Is it right? So where you can calculate alpha as the difference between theta and 2 pi per 3. Right. So then you get for sector 3. I mean this one. Okay. Okay, so then we can move for the next step to calculate V alpha and V beta here. Okay. So how to calculate V alpha and V beta? So we have discussed the calculation part. And for part A, so where and V beta, which one? I think here, right? I need this one. Calculate V alpha and V beta. So where you have already calculated the alpha, alpha you have calculated. So then by applying the alpha, then you can calculate the alpha and V beta using the trigonal function. Is it right? To calculate V alpha, you apply cos function, and to calculate V beta, you apply the sine function. And so this case, the V is the magnitude of the space vector. So remember, V will be the magnitude of the space vector. Okay. Okay, so okay, then you can apply this equation. You can use this equation to write the coding here. How is it? So here, maybe you can define V alpha is the magnitude. Maybe you can look at here, above here. You have already write the coding for calculate the magnitude. Is right? So then V, you apply the V here, this one, V, the variable here, V, capital letter. So then V is, you multiply by shift 8 cos alpha. Sorry. Yeah. Sorry, 9. Okay, so don't forget to put semicolon. Is it right? Maybe I can check with the okay, for V beta. Then for V beta, you V beta equal to for V beta. So this is the answer. How to open in new figure? Okay. So maybe this is my reference. Okay, for V beta equal to the magnitude multiplied by cos. Sorry, for V alpha is cos, beta is sine. Okay, siapa? Okay, V beta. You apply the sine function. So maybe you can write the comment here. So to write the comment, so you need to put the symbol percentage here. So then this one, maybe you apply equation tu lah. Sorry, no need lah. No need to write the comment. Okay, then next step, to calculate the on duration. So which equation need to be applied? I see here, this equation. You have equation for TA, TB, this one, and TZ. Okay, so you just apply the equation. So mean here, maybe you write as TA. And you must put in general, no need to specify the number. No need to specify the on time for every sector. Just put in general. So mean you put TA. TA is, so here what 3 divided by 2 is 1.5. Then you multiply, T is the switching period. So remember, you have defined the t variable above here. Based on the question given in the assignment. So you need to design your modulator where the switching frequency must be 1 kilohertz. So T is the inversion of the frequency. So then you have T here. Then you need to multiply, divide by VDC, right? VDC, you have VDC here. Then open bracket. So in the bracket term will be V alpha, V alpha. The difference between V alpha and V beta. Sorry, V beta divide by square root of 3. Then don't forget to put the close bracket and the semicolon. Ini semicolon kan? Semicolon symbol. Okay. Okay, for TB equal to, so from here you apply this equation, right? So where TB is square root of 3 multiply by the switching period T multiply V beta divide by VDC. Sorry, here square root of 3. Yes, 3T V beta divide by VDC. Okay. Semicolon. Then easy. So where the time taken to select 0 vectors, V0 or V7. So you can obtain as the difference between T and the summation of EA plus EB. Okay. Okay. Okay, so maybe you can check your coding by comparing the calculation here and the simulation result. Okay, so let's say we want to check. Okay, so you need to define the output. Hilang pula. Okay, define the output here. Batuk. So TA, then you put TB and TZ. Okay, to check the output. We compare the calculation value here, 296, 556, and 147 for TZ. Okay, before that, I think maybe you need to put. Okay, no need. Okay. All right. So you close this one. So where the output now is TA, TB, TZ. So you go to the simulation model here. So in order to compare with the calculation, since from the question given, your VD and VQ is what? So where's your VD and VQ? VD and VQ. This one, honey. Okay, we have calculate this one, VD. So mean you need to, sorry. Okay, you need to replace this block. Okay, you remove the block with the constant block. So maybe you can you double click and write constant, then enter. Okay, so this block represent the value of VD. So where your VD is what? 10.4189. Hey, tak keluar? Sorry, 10.4889. Okay. Then another block here, you can copy by point your mouse cursor on the block, then right click, pull, drag to here. Then you can change the value as minus 59.0885. Okay. So for the correction given, the information given is this one. So where the magnitude is 60 and the angle is minus 80. Minus 80. Boleh? So where your vector located in sector what? Sector 5. Is it right? Sector 5. Here is sector 5. This one sector 6. Ada apa? Okay. Okay, maybe we can put the output, extra and additional output to check, to verify the coding that we have developed just now. So where maybe we can put additional output as what? Sector. So maybe you can put sector alpha just to check. Okay. So you have 5 outputs. Is it right? 5 output. So then from here, you need to double click the Dmax box. So this is the Dmax. So where a single input, multi output. So then you can double click to change the number of output. So now you have 5 output. Okay. So then from here, so maybe you can use suitable block to verify the result. So to verify your design, maybe you can add what is a stable block. Display. So display actually is the meter. So then you can give the numbers, the answer in numbers. Using scope, you get in wave shape, waveform. So display, you just double click display. You double click, then you type text display. Otherwise, you can find the block from here, library browser. Okay. Under Simulink library, go to the sinks. So they provide the list of components to measure the output. Whether you want to visualize the result in wave shape or produce the numbers. Display dia akan produce the numbers macam meter lah. Okay. Then you can put for the other output port ni. So you have 5, right? 5. Just to check. Ni optional. So in doing research, you cannot ambitious. You just completely construct the model, then you run. So you need to develop step by step to check. So this is the correct way. Okay, then you can run the simulation. Okay, 2%. Compile, sorry, compile. First, the simulation. Okay. Why cannot? So here you have 5, right? This one 5. Why they don't put the produce the output? V, okay. Cannot. Sector. We define sector, right? This one sector. Sector 1. Alpha. Maybe we need to put The initial value of alpha. So let me try first. For 0. And then run simulation. Still error. Lama. The input is okay, but the output. The error due to what? VDC, undefined variable VDC. We don't define the value of VDC, right? I think we have already defined the VDC. Or maybe I write in small letter here. This one, okay, here. So you need to write the code properly. Use appropriate syntax. To write the instruction of the coding. VDC in capital letter. And then run. Run the simulation. Takes time. Ada lagi? EA exit 11 VDC for array. 2 error. Here I think okay, right? 150 VDC. So maybe this one need to put the symbol ni, multiply symbol. Is it right? But this one no need. Okay, just try. Okay. So make sure you put ni the multiply symbol, star symbol. Okay. So true, is it right? This is for sector. Here is sector. Maybe I can put here is sector. Here we produce the output for sector. This one what? For output number 2, alpha. Here alpha. You have set first output is sector, second is alpha. Third output is what? TA, TB, TZ. TA, TB. Coding tak betul. TZ. Okay, then you can compare the simulation result with the calculation. Sector is 5, correct? For alpha, where is the alpha? Here, alpha, 40 degrees. But here in radian. So someone can you try to convert the value? This one in radian. So you need to compare to convert into degrees. Is it right? 40 degrees. Syahada, kira ni. Convert this value to degrees. The MATLAB provide the answer in radian. So then TA. TA true, right? Same. 296.2 micro. Here. Betul TB. 556.7. And TZ. 147. Betul? Okay, betul So the MATLAB produce the answer in radian. The calculation in degrees, 40 degrees. Okay? Tunjuklah coding ni. So this is the answer. And the coding here, right? VD, VQ. How to calculate VD and VQ? So you must know how to differentiate the definition of VD, VQ and V alpha, V beta. V alpha, V beta, we apply for apa? The analysis for in sector, within a sector. Kalau VD, VQ means you need to apply the space, you analyze the space vector on DQ axis lah, betul. Faham Okay, nanti saya tengok. Okay, so for VD, VQ, so means from here, let's say here kan. So maybe I need to copy first the diagram here. Okay, to differentiate the definition of V alpha, V beta, and VD, VQ. Okay, firstly, alamak, mana ni? Here, put here. So the question given the question give the space vector locate here, right? So the space vector V. So where the magnitude is what? 80 Saya lupa 60 minus 80 degrees. How to differentiate V alpha, V beta versus VD, VQ. Ni. Okay, class. Okay, for VD, VQ. To calculate VD, VQ, okay, maybe I need to sketch this one properly. So here your space vector, right? So this is your space vector. Okay, VD, VQ, you can you can obtain the VD, VQ. So if you analyze the space vector on DQ axis, D axis and Q axis. So mean here will be your angle, right? Theta. So this case your VD based on the diagram here, so you can define your VD will be here, right? This is your VD. And the vector here is your VQ. Right? Okay. So maybe I need to draw properly here. So where you can define here VD and VQ. Right? So this is the right angle. Here is the right angle. So from here, we know that the angle given is 80 degrees, right? The 80 degree, this angle. So where you can calculate VD as 60 cos, right? Cos 80. VD will be positive because your space vector on the right hand side from the y-axis, q-axis. Okay, and your VQ will be negative, right? Because below the time axis or below the d-axis, right? D in the real axis. So your space vector below the d-axis, so here will be negative. The magnitude multiplied by sine 80 degrees. Okay, clear? Okay, for V alpha, V beta. So you need to analyze the space vector on alpha and beta axis. Alpha and beta axis. Alright. Penting kan? Nasib baik you tanya soalan ni. Okay, where first, since your space vector located in sector 5, right? Sector 5, kan? So where the first adjacent vector to be selected within a switching period, mean in interval number 2, this case is V5, right? V5. So is V5. The angle you can define the difference from the space vector and V5. So this is your alpha. So means from here we know that and the alpha also you can define as the difference between the space vector and VA or alpha axis. So remember your VA, you draw the VA must be in line with the alpha axis. So mean your alpha axis will be, maybe I draw different color, the red color. So this is your alpha axis. And the the beta axis will be where? Yang ni ke or here? Here kan? So this will be beta axis. Okay. The positive, beta positive axis, alpha axis. So then by analyzing the space vector on alpha and beta axis, so then from here you can calculate or obtain V alpha and V beta. And V alpha and beta, which one? Pada apa nak makan? So here maybe I use which color? Magenta. So from here your V alpha will be here, right? In line with the alpha axis. So this is your V alpha. And V beta, is it right? So where you can write the equation of V alpha as the magnitude still same, 60, right? So here you apply the cost function where the term in bracket is alpha, it's not theta. For V beta is 60 sine alpha. Okay. So in this case, we can say that your V alpha and V beta values must be positive. It cannot be negative. Because you analyze the space vector on alpha and beta axis plane. Clear? Okay, let's say give one more example. Copy. Sorry, Control V, paste. Here. Okay, let's say now your space vector located here. This is your space vector in sector 3. Okay. So where the angle will be, this is your angle given, theta. Let's say your space vector now is, the magnitude is what? 50 volt. The angle will be what? So since in sector 3, so the angle maybe we put what? Here it will be 120 degrees. Here is 180. So maybe we can put 150 degrees, right? Any example? Example. Okay, so from here, I mean this angle is 150 degrees. Okay, calculate VD/VQ first. We differentiate the definition VD and VQ and versus V alpha, V beta. Okay, VD/VQ. So mean here, because we analyze the space vector on DQ axis. DQ axis, so your V alpha will be here, right? Sorry, V alpha, VD. So mean your VD must be in negative value. And your VQ, I mean this is your VQ, right? We can put the line here. Okay. Sorry, So then from here you can calculate your VD as what? The magnitude is 50. So you must use cost function where the angle, where is the angle? So I mean here you can calculate the angle as 180 degrees minus 150 degrees, right? You calculate this angle. Okay. Just apply the trigonal function you learn from apa? First year subject mathematics subject. VQ. Okay, VD. So you so here the answer must be negative. Sorry. Okay. So VD here must be negative because your space vector located on the left-hand side from the Q axis. Okay, VQ. So for VQ must be positive, positive 50 sine 30 degrees. Okay, or the difference between 180 and 150. Okay, so this the angle here will be 30 degrees. Okay, okay, now to calculate V alpha and V beta. So from here, your V alpha, firstly, since your space vector located in sector 3, so you need to identify first the adjacent vector to be selected within a switching period. So mean in interval number 2. Interval number 4, you need to choose 0 vector. Interval number 2, what? VA. So your VA will be V3. So your V3 is VA. Okay. So means you need to draw the alpha axis will be here, right? Must be in line with the V3. So this is your alpha axis. And for the beta, which one? Here or here? So must be this point, eh? Okay. So where this is the right angle. Alpha and beta, the different angle is 90 degrees, eh? The right angle. Let me erase. Okay. Okay, then you can sketch the component vector for V alpha and V beta. So where your V alpha will be here, right? Maybe I use different color. Which color to be used? Green color. So this is your V alpha and V beta. This one, right? Okay, maybe you can draw the line here, the projection line. Okay. Okay, V alpha, because in order to calculate V alpha, so you need to calculate the alpha and the angle alpha, right? So V alpha, you apply cos function. The bracket term will be alpha. So what is the alpha? The alpha, you apply the definition and the different angle between the space vector and VA. So the alpha will be ini. Kalau apa nak pakai? This one. So this is your alpha. Okay. So where your alpha you can calculate it as 150 degrees, right? Minus 120 degrees. So you get 30 degrees. Okay. Okay, so here don't forget, and this is your theta. This is your theta. Okay, class. Boleh? You must understand how to differentiate between the theta and alpha, VDVQ and V alpha, V beta. For tomorrow test. Term. Okay, so then from here you can calculate V beta as sine alpha. And so remember your alpha is 30 degrees. Okay, alpha and beta, the value must always positive. It cannot be negative. Okay, but for VD and VQ, the value can be negative values. Clear? Same goes for alpha and the value of alpha. It cannot be negative because we analyze you on the alpha and beta axis. It's not DQ axis. Okay. Then you will compare the result are exactly same with the calculation value, simulation and experiment. Maybe line is not clear. Poor network connection. Okay, the last step, you need to calculate the duty ratio. This one will I not discuss in class because this is assignment. Okay, assignment should be student do it by your own self lah. Based on your punya logical thinking and your skill and how to completely design the model. Okay. Okay, so remember for the space vector, so we have discussed. Let me open the one knot first. Where is my one knot? One knot. The knots that we have discussed in class. So remember, in order to develop the modulator, the space vector modulator, so you have the important section here. One of the important section is to determine the sequence of the switching vector. Okay, switching vector. You ada part ni. First, this section is switching the vectors. To calculate the on time, I think this one, and this section. To the sequence of the switching vector. Macam mana you nak set or design which vector need to be selected in order. Okay. Okay, so let's say this one, we move we start from the sector number 1 here, sector number 1. Okay. Maybe I think I need to open my old knot here. Sorry, let me open first the knot. Mana which subject MEKG. Which subject I share to you. Actually, this this content for SVM is master program subject. It's not degree. 5143. 5143. Which code and which subject? 5. Lines. Alamak, tak ada. Sorry. It's not. Aduh, mana eh? 761 kan. Maybe this one. There we go. Tengok movie je. Okay. Okay, this one is okay. Okay. Now the last step, in order to completely design the space vector modulator. So for the last step, so you need to determine the sequence of the switching vectors for every sector. So we start from sector number 1. Where's the pen? Okay, sector number 1. Okay. So for sector number 1, so since for sector number 1, the first vector to be selected within a switching period T start from 0, right? So where the state are 0, 0, 0. Then for interval number 2 should be V1. So V1 will be your VA, right? Then V2 will be VB. Then go to 0 vector V7 at the middle of the switching period. Okay. Okay, then from here, okay. So mean for the last step, you need to calculate the duty ratio, dA, dB, and dC. Okay, so in order to produce the switching state, so remember your switching state varies from 0 to 1. So mean it is a digital output, digitized output. It's not the analog. So where the output or the switching state varies from 0 to 1. So you can produce the output by comparing between the DA signal, the respective DA signal, and the triangular waveform. Nampak ni triangular, so this is your triangular waveform. For one cycle, for one complete cycle. Okay, nampak dia jumpa peak to peak. So we define this as the T, the period of the triangular waveform. So where the switching status, for example, SA, it can produce either 0 and 1. So when it produces 0, when your the triangular waveform larger than dA. So the triangular waveform larger than dA. Senang kan? So this is your dA. So dA is the duty cycle for switching status SA. So when the triangle larger than ni, so then the output will be 0. So same goes to here. And interval number 1 and interval number 8. Okay. Otherwise, it will produce status 1. And ini simple lah, macam you study for a sinusoidal pulse width modulation. Okay. Okay. So same goes for the other switching state, SB and SC. So you need to compare the triangular waveform and their respective duty ratio. Okay, duty ratio, clear? Clear. So maybe I can write in general where the switching state SX. So your XX, X can be A, B, or C. Okay. So it can produce either 1 or 0 if what? If dx, I write in general, dx is larger than or equal to triangular. So ni otherwise. So mean if the duty ratio less than triangular waveform. So where your X, I put in general, it can be phase A, B, or C. Yeah, so this is for sector number 1. So maybe we can say that. Okay, sorry. Okay, so to calculate dA, so you must get the equation for dA, dB, and dC. So try to understand how to get the equation. Okay, so for dA, so we know that in general, the duty ratio is the ratio between on time divided by T. Right? T on divided by T. So you can calculate T on as which one? Which is the T on for dA? So here, right? The on time. So this is your T on for dA. So where you can calculate T on as the difference between the switching period T and 2 times of Tz divided by 4. Okay. Right? So maybe we can say that the T on is the difference between T and T off, right? So where your T off is, T off will be here. Here and here. So this interval is Tz divided by 4. Here also Tz divided by 4. Since you have 2 intervals, you need to multiply by 2. Right? So where your T on for dA is the difference between the switching period and 2 times of Tz divided by 4. Right? Then we try to okay, we know that Tz is the difference between the switching period and summation of Ta and Tb. So then you can substitute to here, the highlighter. Okay. Okay, then we go for Tb. How to calculate for dB? So we still apply the general definition here, where the duty ratio is the ratio between on time divided by switching period. Okay, now T on. So this is the T on, right? So where the T on, so if you look at from the diagram, so we can define the T on starting from this point to here. Is it right? Because the state is 1. SB is 1. So means the top switch for the phase B, the leg number 2, is the switch is turned on. Yeah. So here is your T on now. So where you can calculate T on as. So firstly, you need to obtain the time for here. Here, this one. Also, and this interval. So mean the blue color arrow is the T off. So that T off there, because the state is 0. Clear? So mean you get your T off is Ta divided by 2, you multiply by 2, and Tz divided by 4, multiply by 2. Then you get this equation, the bracket term equation. Okay, clear? Okay. Boleh faham? Alright, then you can analyze the same technique for DC. For DC. So means this is your T off. Right? This term is your T off. So your T off is here, right? So this is your off time. So you have the term of Tz, Ta, and Tb. Right? Boleh faham ni? Senang kan? Like that. Okay, this is for the sector number 1, the first case. Okay, case number 2, sector 2. Sector 2. Jeng, jeng, jeng. sector number 2. So you can see what is the difference. Okay, you can see DA on the top, the highest, right? Then, sector 2 macam ni kan? DB, okay, DB, betul lah, DB and DC. Okay, sector number 2, remember, sector number 2. You have this vector, right? You have V1, V2, V3. We just write for sector number 2 here. Sector number 2. Because we focus on sector number 2. Okay, the state of V2, what? What is the state of V2? Apa V2? 110. Okay, 110. V3? 010. So mean your VA will be V3. Clear? So the sequence of vector, so means for in one switching period, so the first vector selected is V0. And so remember, for any sector, the first vector to be selected is V0. So mean the combination state are 0, 0, 0, V0. Then the first adjacent vector will be V3. So, so then go for V2, jump to V7, at the middle, V2, V3, V0. Okay? So then you get this switching status profile. Right? Okay, so mean here, from here you can apply the same technique to calculate the DA, DB, and DC. So please analyze. Check the question. Is it right or not? So your DA is the difference between the switching period and this is your off time. So this is your T off. For DB, this one will be the T off. And here also T off. I mean for DA, you can calculate off time by summing this interval, right? The blue color. And okay, in order to produce appropriate sequence of vectors, so of course you need to sketch the switching status waveform. Okay, so from there you can write the equations. Okay, clear? Okay, this for sector number 2. Sector number 3. Well, sector number 3, you can see the off time. So it cover for 6 interval, 3 on the left hand side and another 3 for the right hand side. So you can calculate the off time here. Okay, I need for DB and DC. Okay, again, before you write the equations, you must firstly sketch the switching status waveform. Okay, then sector 3, 4, 5, and 6. Okay. Okay, based on the equation that we have obtained, then you can write the coding. And this is the flow chart. So firstly, you calculate the DQ, calculate the magnitude and angle. Then the next step, detect the sector, calculate the alpha within a sector, calculate the alpha V beta, calculate the on time. Then this last step, you calculate the duty ratio. Okay, DA, DB, DC. Okay, so then that's compare. Try to write the coding here, right? This is the coding. Okay, this one. Okay, maybe I just copy from my. Okay, firstly, This. This for the sector number 1. Try to understand by comparing the coding and the diagram here. For the case of sector number 1, sorry. Maybe here. Okay. Sector number 1. Dua angle masa apa dapat tembak. BEC is ada Okay, sector 1, okay, same. So this is for sector 2. Tulis semua. Sector 1, sector 2. Please check.
Halo dokter.
Hello. Okay, make sure you understand how to get all the equations based on the diagram. Maybe that this slide I will provide you. I will share this slide for you to analyze in order to get all the equations. Okay. Yeah. Okay, so you have do this part. So means we have completely model the modulator here. Which block? This one. Okay. Okay, so to produce the switching state, so maybe we need to change the output here. Okay, so please change the output. Because before this, we just do for this one to verify the coding. So you have to change the output now to DA, DB, DC. So mean this block is responsible to produce the duty ratio for each phase, DA, DB, DC. You have three outputs. Yeah, DA, DB, DC. So don't forget to put semicolon here. Right? Your output of the modulator here, the green color block. So you will have three outputs, DA, DB, DC. Okay, then okay, so I think that you can now remove this component, all these components. Okay, then you can copy from the file that I have given to you. which is this block. Okay, at the end, this block. You can obtain this block from the file given. And the file that you have downloaded from MTIM. You just copy this block. So you connect. Okay, so means this signal, it will carry the signal for DA, DB, and DC. So one line carry 3 signals, DA, DB, DC, which are the output from the SVM modulator. Correct? So don't forget, so you must set the output as SV modulator are DA, DB, DC. Right. Boleh faham Okay, maksudnya your modulator block here. Sorry, maybe this one I put here. Okay. Yang MATLAB function, the green color we have already designed. We write the code completely. So where the MATLAB function block, the inputs are references, BG and BQ, correct? BG and BQ. And the output will be duty ratio, DA, DB, DC. Okay. So this line actually carry 3 signals. Duty cycle for DA, DB, DC. Okay, you open the block by double clicking this block. This subsystem. Nampak? Ini answer given ini. Okay, because you need to compare the duty ratio signals with a single carrier, the triangular waveform here, in order to produce the switching state here, where this switching state are used to turn on the power switches of the inverter, especially for the top switch for each leg. Clear? Ini sama macam you study for sinusoidal pulse width modulation technique. To produce the switching state, you compare the duty cycle or the modulating signal with a single carrier. Okay, how to design the triangular? Triangular saya lagi macam mana? Tidak complete inverter. So you must know how to design the triangular. So let's say this block actually we obtain from simulating library, or you may write or text here, repeating sequence. To obtain the, is it right? Cannot. How to spell repeating sequence? This block, repeating sequence. Spelling is okay, right? Repeating sequence. Why cannot? Repeating sequence. Dah ada. Okay, to design the triangular, because you have, in order to use this block, so actually you need to design for one complete cycle of triangular. You need to design for one complete cycle of triangular wave shape. So you can see here, you double click this block. So you must fill up for these two rows, time values and output values. Okay, so means in order to design the triangular, actually you need to identify the 3 important points to sketch or design one complete cycle of triangular. So where you have the first time is 0, then here will be half of the switching period. Berapa ni? 0.5 bagi apa? 1 divided by F. Right. Then your T will be here, the third point. 1000. Okay, let me put this one first. So where your triangular varies between 0 and 1. Is it right? 0 and 1. Sorry, maybe we put initially is 1, 0, 1. So actually you try to draw or design this triangular. This triangular. Where's my pen? Okay. Since you apply this repeating sequence block, so mean you need to design for one complete cycle of triangular. So this case, you actually have 3 points. Point number 1, point number 2, point number 3. At point number 1, and so where your time is 0, the output will be 1. And the x is 0, y is 1. For point number 2, your time is what? Half of t, right? And the output will be 0. Point number 3, ini dah tahu kan? T, where the output will be 1. So remember your T is 1 divided by F, which is 1000. So from there you can completely fill up these two parameter box. One for the time varies, another one is output varies. Okay, we know how to setting in let subject. Set here let subject. All right. So then after you design for one complete cycle of waveform, triangular waveform, then this block will be the waveform will be repeated. So that's why we this block name as the repeating sequence. So it will repeat for the one complete of the cycle, the waveform. Okay. So then you can press OK. So remember, the output varies from 0 to 1 because from the diagram here, the triangular varies from 0 to 1. 0, 1, go to 0, then 1. Okay. So then you OK, press the OK button. Then you can run to verify the design. Okay. It's locked. So maybe we can verify using the dashboard scope. Dashboard scope, sorry. How to so maybe I can show you how to connect. So maybe we can define this as V tri. VRPI, right? V triangular. Okay, in order to plot onto the dashboard scope, so you can double click to connect this signal, V tri signal. You double click this block. Okay, you double click. Tak keluar. Why the should be even list of all the signals here. Kenapa tak keluar? Nampak? Or maybe you can use the scope. Sorry, you can use the scope. Scope, where's the scope? Sing, under Sing library, go to scope here. Okay, then you can check your design. Is it right or not? Okay. You play the run button. Okay, this one is optional. No need to do this one. I just have to show you. Ada area lain pula DA. Okay, tak apalah. This one only to verify. You can maybe you can copy these two blocks, then you try to create new file because maybe the error comes from here. I think this one you need to completely construct all the model. Okay, so then here you get Okay, this one here, same, where the output varies from 1 to 0, the time value 0, half of switching period, and T here. Then you compare, then you will produce the switching state. Okay, try to run the simulation. Is it okay? Right? BA, okay, maybe you need to, sorry, Okay, one thing. You need to set the initial value of the duty ratio here. Sorry, this initial part here. So maybe DA use all duty ratio you set 0. DB equal to 0. DC equal to 0. Okay. So you must set the initial values of the output signals. DA, DB, DC. And then you can run the simulation. Still error? Okay, no error. Okay, no error. Yeah, alhamdulillah. Okay, we try to compare the simulation result with the calculation that we have discussed last week. So this case, you can use the scope. Saya ambil scope, scope. Okay, the scope ni you can set. It has 3 inputs. So maybe you can set from here. You double click the scope. Okay, then from here actually you can set. The scope has 3 graph axis. You click this setting button. So by default, the value this one is 1. You need to change to 3. Okay. So then you click the layout. Then you drag to select for 3. So it means you have 3 graph axis. Okay. And then you just explore. Try. Okay, then you connect here, this one, and here. Okay. Okay. So by applying the input VD VQ as calculated in class last week, you get 10.4 something minus 59. Then now you can verify the simulation. Right? Okay, one thing. So you need to put the sample and hold block. Okay, this signal, this line you need to remove. Okay, then you take from the file given. I think from the file given. Okay. So this block name is 0 and hold, I think. Maybe format show the name of the block. So zero order hold. This block name is